Hi friends, today let us solve the transportation problem, the initial solution by Vogel's approximation method, that is VAM method. Let us look at the problem. So this is the problem. Find the initial solution to the following transportation problem using VAM method. So this is the problem. Anyway, we will see how to solve this problem. So this is the problem what is given, solution. So first thing what we will do is we need to see whether demand and supply are equal. So the demand and supply both are equal. We have already seen this. So hence the feasible solution exists for this problem, so that we can go ahead with the further solution of the problem. Once we are confirmed that there is a feasible solution for this problem, we can solve the problem by VAM method, that is Vogel's approximation method. So how to solve this? The steps here are: first you need to find out the penalty cost for the supply and demand. Okay, so how to find out the penalty costs for each column and rows? So you have to write P1 here and P1 here, because we need to go on with P1, P2 like that, several iterations of penalty cost. So the first iteration is P1. So how to find out the penalty cost? So for this row, if we want to find out the penalty cost, we need to find out the least cell value. Here the least cell value is 2, but there is one more value 2 here. You can take any one of them and we can subtract this 2 from the next highest value. Next highest value is 4. 4 minus 2 is 2. So the first penalty cost is 2 here. Similarly, here the least value is 1. The next least value is 3. 3 minus 1 is 2. Now here the least value is 4. The next to the least value is 5. 5 minus 4 is 1. Similarly, here least value is 1. Here it is 2. 2 minus 1 is 1. Similarly, for this penalty costs, for column wise, we need to see columns. For the first column, here the least value is 1, and the next two least value is 2. 2 minus 1 is 1. Similarly, 3 minus 2, 1, and here 2 minus 1 is 1. So we have found the first iteration of the penalty cost. We need to find out the highest penalty cost in the first iteration. Here in this, the highest is 1. Here in this, highest is 2. But we have to take the highest value and go to that respective column or the row. But here we have two 2's. So which one to go? Even there are two different highest values, you can go for any one. You can either go with this or you can go with this. So in this problem, I want to go with this one. So I will put a small arrow here, kind of a thing. Okay, that I am referring to this column. So in this particular row, which is the least value, I have to choose the least value and do the allocation there. The least value is 2, but there is one more 2 here. Which one to allocate? Whichever you want. If there are more than 2 least values, you can allocate to any one. So for this particular problem, I am going to allocate for this particular least value. For this particular least value, the values are 5 and 7. So which is least? 5. So I will allocate 5 here. So 5 minus 5 is 0. 7 minus 5 is 2. So I will write 2 here. Since it is 0, there is this row is exhausted because there are nothing stock left. So it is 0. So I have to repeat with the penalty cost again. So I have to write penalty cost 2. In that first row is exhausted, so I will put a dash there. In the second row, 3 minus 1 is 2. Now 5 minus 4 is 1. Here the least value is 1. 2 minus 1 is 1. So again for columns also I have to take another penalty cost. Here least value is 1, next to it is 3, 3 minus 1 is 2, because here 2 was there, but this has been exhausted. So I have to take the next least value is 3. 3 minus 1 is 2. So here the least value is 3, next to it is 4, 4 minus 3 is 1, here it is 2 minus 1, 1. So in this penalty cost, which is the highest? Here it is highest is 2, here it is 2. Again we are getting 2 values. Here also we are getting 2, here also we are getting 2. So which one to go? You can go with that one or you can go with this one. So in this case, I will choose to go with this 2. So I will put a small arrow here. A small arrow to identify that I am going through this column. In this column, which is the least value? Here it is 1. So 1 is the least value, I have to allocate for this one. So 2 and 14 is there. How much I can allocate? 2. So I will write 2 here. I will write 2 here. So 2 minus 2 is 0. 14 minus 2 is 12. So this row, column has been exhausted. So I will just put a line there. So I have a 3 by 2 matrix. So again I have to come up with P3. That is first row is dash. 3 minus 1 is 2. 7 minus 4 is 3. 6 minus 2 is 4. Here P3. This is dash. Here the least value is 3. Next least is 4. 4 minus 3 is 1. Here it is 2 minus 1 is 1. So amongst this, which is the highest penalty cost? The highest penalty cost in the P3 penalty cost is 4. So I have to go with this 4 inside. So I'll put a small arrow here that I'm going through this row. So which is the least in this row? Least cell value. The least cell value is 2. So I have to make the allocations for this 2. So for the 2, 12 and 18 is there. So I'll allocate 12. Correct? So this becomes 0 and 18 minus 12 is 6. So I will strike this because this is exhausted. Okay. So again I have to come up with the fourth iteration of the penalty cost, P4, and here also it is P4. For the first row it is dash again. 3 minus 1 is 2. 7 minus 4 is 3. Here again this is exhausted, so I will put a dash here. Okay. So again here I will see this column is not exhausted, so I will put a dash. Here 4 minus 3 is 1, and again 7 minus 4 is, it is 6. So which is the highest penalty cost in this P4 series? It is 6. 6 is the highest value. There is it is reflecting only once, so I will go in drill into this particular column. So when I go into this particular column, which is the least cell I have got? 1 and 1. So I will have to allocate for 1. So 8 and 6 are there, which is minimum. So I will allocate 6. Once I allocate 6, 8 minus 6 is 2. So this becomes, this column is again exhausted. So I have to come up with one more iteration, that is called P5. So in this iteration of penalty cost, first one is dash, second one is there is nothing to subtract, so 3 is the only value. I will write 3 here directly. Here 4 is the only value, so 4 minus 0 is again 4. Here there is nothing left, this is exhausted, so that is dash. Now I have to do penalty cost for this P5 also. Here in this column nothing is remaining, so it is dash. Second column 4 minus 3 is 1. So in this last column nothing is remaining, so that's why it is dash here. So which is the highest value what we got in the fifth penalty cost series? It is 4. Once we got the 4 value, we need to drill down into that 4 value. So I'll put a small arrow here just to notify, and when I go here, the only cell I've got is 4, so I have to do allocation for 4 only. There is no minimum maximum here, just one cell. So for 4, 9 and 7 is there. 7 I should allocate. Once I allocate 7, nothing is remaining here. 9 minus 7 is 2. So it has been exhausted. So the last cell remains. You don't have to go out with one more penalty cost because not required. Only one cell is remaining. Here for this particular cell 3, I have got 2 and 2. So equal is there. So I have done the problem correctly. So I'll write 2 here and close it. So in this way, through Vogel's approximation method, I have allocated all the demand and supply. Once allocation is done, what is the third step we need to do? Find the total cost. Before I find the total cost, I will take this penalty cost from here because ease of operations. I'll get more space. Okay. So here I have got space. Right. So what I am trying to find out now is the total cost. Alright. I am trying to find out the total cost. The total cost is equal to O1 D1. I need to write down all the allocated cell. O1 D1 plus O2 D2. Here it is O2 D3 plus O3 D2 plus O4 D1 plus O4 D3. Right? Once having got this, I need to write the numbers here. 2 into first O1 D1 is 2 into 5 plus 3 into 2 right, 1 into 6 plus 4 into 7, 4 into 7, 1 into 2 plus 12 into 2. Into 12. Okay, fine. So if we work this out, the total answer what you will get is 76 is the answer. Now the next step what we need to do, as we already know, that is find whether this solution is a basic feasible solution or a degenerate solution. So how to find out that? We need to check the, so I will put a line here. The next step, number of allocations. How many number of allocations we have? 1, 2, 3, 4, 5 and 6. Total number of allocations are 6. And if we try to do the equation, that is m plus n minus 1, that is we had 4 rows and 3 columns, that is 4 plus 3 minus 1 is equal to 6. Both the number of allocations and the m plus n minus 1 both are 6. Therefore, the solution is called basic feasible solution. Okay, only when it is basic feasible solution you can go ahead with the optimality test. If it is not a basic feasible solution, if both the things are not equal, then it is called as degenerate feasible solution. So actually we have got the right thing, that is basic feasible solution. If we got this, if they ask, then you can go with the optimality test. Otherwise you can leave it here. This is how we can solve the problems through VAM method, that is Vogel's approximation method. Thank you for watching. See you in the next video.